Okay, so hi everyone, I'm Mihai here. Today we're finally looking at Entity Framework Core and domain-driven design. I know this is a topic that many of you have been waiting for a long time, a couple of months already. So you've been waiting patiently, and today it's finally happening. So this is a special video in which we're going to cover many topics. So we're going to cover also everything you need to know to get started with domain-driven design and Entity Framework Core, and then we'll cover the actual steps that you'll need to take your aggregates, whatever they are, however complex they are, and map them to the corresponding relational database tables. Then we'll see how we can use the Fluent API in Entity Framework Core to actually do the mapping between the aggregate and the database. Then we'll see how we can create a SQL Server on a Docker container and use the Entity Framework Core CLI tool or .NET CLI tool to connect to the database and do the various actions. So if it's the migrations, updating the database, and so on. And we'll also use Visual Studio Code to explore the database. So there's going to be a lot going on. We're going to cover a lot of topics. This video is going to be dense and intense. But by the end of this video, if you watch until the end, then I think you'll have everything you need to know to use Entity Framework Core in your applications following domain-driven design principles. There are some mistakes and nuances that are very important to know if you're working with Entity Framework Core. And I think that there are many applications that do this wrong. And the only reason that they don't break or they don't see these bugs is by chance. And tomorrow morning, their application might break. So even if you're already using Entity Framework Core in your applications with domain-driven design, I encourage you to watch until the end and make sure that you're doing it correctly in your application. So there's a lot to talk about. Let's get started. First, let's understand why it's even a big deal using Entity Framework Core with domain-driven design and why it's not so trivial. So the first thing, if you've been following my series of building a REST API completely from scratch, following clean architecture and domain-driven design principles, then you noticed that we haven't talked about the database yet at all. This is the first time that we're talking about the database. If we're going to use a relational database, if we're going to use a document database, what database provider we're going to use, we haven't talked about this yet. And that's because we wanted to follow persistence ignorance, which means you don't care about the storage solution while you're defining your domain layer. This shouldn't be a concern. And that's something that we want to keep in mind. Okay, now there are things that we talked about in domain-driven design that we want to enforce when mapping our aggregates to the database. This is something that is done wrong in many applications. So let's cover this. The first thing is that the identifier of the aggregate ID, needs to be unique within the entire system, which means that if we have two aggregates, aggregate 1 and aggregate 2, their IDs must be different within the entire system. Okay, moving on to the second building block. So that is that the entity needs to be unique within the aggregate. So I invented an acronym, which is AUID, which means aggregate unique identifier. So the entity ID needs to be unique within the aggregate. So if we're looking at it one next to the other, then if we have two entities, then they can have the same ID as long as they're sitting within two separate aggregates. Okay, so the following is legal. And moving on to the third one, so value objects don't have an identifier. And if we put everything together, then we don't want changes to one aggregate to affect other aggregates. And this is where it comes into play, because even though in memory, we just have reference between objects, and ideally, we're not deleting entities that the reference of the object is shared between two aggregate objects. But when it comes to the database, then if we have, for example, the following, so we have two aggregates and both of them have inside an entity with the ID of 1. These are different entities logically, even though they have the same entity ID. We need to be careful that when we're mapping it to the tables that we don't do the following mistakes. So we want to make sure that the ID of the entity is not the primary key of that entity table, because if it is, then what happens is that when we delete the entity with the ID of 1, then we essentially deleted both of these entities, even though they're logically different entities. So that's something that's very important to notice and keep in mind when we're mapping it to the database. What we're going to do today is we're going to take a complex object and we'll see how we can map it to the database or to the database tables. This isn't going to be trivial, and we're going to do it in a few different ways so you're familiar with the different options. And this is something that if it doesn't make sense to you yet, then hopefully as the video progresses, then it will make more sense, okay? So up until now in the series, then this is what we have, right? So this is what our application looks like. And what we're going to do today is specifically in the domain layer. So we have the menu aggregate that looks like this. In a minute, we'll look at the JSON representation of it. But just reminding you that what we have is we have the menu aggregate, which internally has many menu sections, and each menu section has many menu items, right? Now, each one of the menu section, and the menu item, all of them are entities. So each one of them has an ID, and the menu is the aggregate root of the entire menu aggregate, okay? Now, the IDs of the entities are all value objects, as you can see over here. So each one of them is an object, which inside has the property of the actual ID value. And that's because we want to be able to change this value from a GUI to a string to something else without having to affect anyone else who has a reference to this menu ID. Great, so we have this. Then the application layer, we have the menu repository. That is how the application layer can actually manipulate the list of menus. So for example, when we create a new menu, then we use the add method in the iMenu repository interface, and the implementation sits over here inside the infrastructure layer. So we have the menu repository, and the menu is sitting over here in memory. And what we're going to do in this video is, instead of using the in-memory database, then we're going to use a SQL Server. Now, you can notice that we have here a few new files. So we're going to have the DB context for our application, which will contain the DB set of menus. And then the menu repository is going to work against this SQL Server using the Boober Dinner DB context instead of working against the list of menus. That's the only change in our application in the infrastructure layer. And that's what we want with persistence ignorance, that the infrastructure layer is the only layer that cares about which database we decide to use. So ideally, what we have is we have over here some interface, or if you decide to use the DB context in your application layer, then the application layer won't change when you switch either the implementation of this interface or the database provider that's used by the DB context, okay? Not saying that it happens a lot, but if it does happen, or logically you want to have this separation, also for testing purposes. Great, so let's talk about the menu aggregate. So this is the menu aggregate, and like we said, so each menu has a list of sections, and each section has a list of items. Other than that, we have here the average rating value object. Like we said, there's no ID in this value object. And other than that, we have here two lists, one list of dinner IDs, which is all the dinner IDs that are serving this menu. And we have also a list of menu review IDs, which is the IDs of all the reviews for this specific menu. Great, so now the question is, how do we take this menu aggregate, which is in the JSON representation here on the left, or you can imagine it in memory, sitting as reference of objects, and how do we take that and we map it to the corresponding SQL tables, okay? So to do this, that's where the configuration file comes into place. So what we looked at before, then over here, we have the actual menu configuration. So that's the way we're going to do this conversion, okay? So each one of the aggregates will have one of these configuration items. Okay, now there are 3 steps for mapping an aggregate to a relational database. So the first step is identifying all the various tables. So the first table we're going to look at is the menus table. This corresponds to the menu aggregate, and this will contain all the properties that aren't complex objects or that are a value object. So looking at the average rating, then we can see we flattened it over here, and it sits simply as 2 columns inside the menus table. And this is using a feature that's called table splitting or table sharing, where you have 2 objects sharing the same table. Okay, so we have the ID, name, description, and average rating over here up until here. Then we have the host ID, which, like we said, it's a value object that stores inside the actual value. So we're flattening that, and we're storing the actual value over here, like you can see. And lastly, we have these 2 date times that are stored over here, and all the rest is mapped to different tables. So let's move on to the other tables. Then we have the sections. So the sections also get a table, and we'll call it menu sections. Then we have inside here the ID, which is mapped to the menu section ID. Then we have the name of the description, where each one of them gets a column as well. Great, moving on to the list of items. So the list of items is very similar to what we had before. So we have over here the menu item ID, and we have here the name of the description that corresponds to what we have over here. Then last but not least, then we have the dinner IDs and menu review IDs, where each one of them also gets a table. Now, if you're familiar with relational databases, then you know this first step is not enough for us to actually map it to a database, because we need to define the relationship between the various tables. We want Entity Framework Core, or the relational database in general, to be able to reconstruct the original menu aggregate based on the data in these tables. Okay, so moving on to step number 2. Then in step number 2, what you want is to add all the various foreign keys that are used to define this relationship. So the menu section needs the menu ID. The menu item needs both the menu section ID and menu ID foreign keys. And each one of the menu dinner IDs needs the menu ID as well. Okay, so after each one of the tables added the corresponding columns to identify the parent entity using the foreign keys, then we could move on to step number 3. Step number 3 is adding all the various SQL constraints. This is where we want to make sure that we're defining our primary keys correctly, so we don't have the situation that we talked about before in the earlier slides. So let's take a look at it now and understand why it's configured the way it is. So starting with the menu section, then we said that the section entity is unique within the menu aggregate. Okay, this means that we can have multiple menu aggregates that all have a section entity with the ID of 1, and then when we delete this entity using its primary key, then we're deleting it across multiple aggregates. That's why we want the primary key of the menu section to not only be the menu section ID, but a combination of both the menu section ID and the menu ID. This is known as a composite key. So we have the menu section ID and the menu ID, and both of them together are the primary key. So generally speaking, there are two ways that you want to take. We'll look at owned entities in a few minutes, but there are two ways to take owned entities and define the relationship between them and the parent. So one of them is to define that the primary key is a composite key of something like we're doing over here. And the other option is to define some key that is a shadow property used for the ID, which will be auto-incremented by the database. And that way we know that the ID indeed is unique, because again, we want to make sure that the ID of each one of the entities in the database is unique following the constraints. So either unique within the entire system or unique within the aggregate. Okay, now if you're looking at this and you're thinking to yourself, what's the big deal? Because each one of these IDs, as you can see, is a GUID, so we don't need to worry about any clashes between them. Then I want you to remember that we want to keep persistence ignorance when we're modeling our domain layer. So we want to be able to switch the IDs from being GUIDs to simply, for example, incrementing inside the aggregate. So each one of the menu section is incrementing, let's say, from 1 to 100 inside the aggregate, and we don't want our database to suddenly break without us knowing. Great, moving on to the menu items. Then the menu item is also an entity. So each one of these is an entity inside the section entity, which is unique within the menu aggregate, which is unique within the entire system. That's why what I configured over here is that both the menu section ID and the menu ID, together with the menu item ID, they compose the primary key of each one of the items. That's the only way that we can guarantee that it's unique within the entire system. Okay, moving on to the dinner IDs and menu review IDs. So this is an interesting case. So what we have over here is a list of value objects. Now I'm asking you, what's the issue with having a list of value objects, and why do we need to introduce here a new column with the ID of the value object? Okay, so the answer is that because it's a value object and it doesn't have a key, even though logically we'll probably have only one dinner ID value per menu. So the same dinner ID shouldn't appear twice inside the dinner IDs list. We don't want to count on that, and we want to introduce some surrogate key that will be incremented per each one of the dinner IDs when we store it in the database, and that way we can guarantee that we are recreating the same object that we stored in the database. So that's what we're doing with the dinner IDs, and the same thing also with the menu review IDs. So I hope that after these steps, then you have a clear understanding of how to take any aggregate that you have and store it in the database. Now, one thing that you want to remember when you're configuring these relationships is that when you delete the menu, then you want all the corresponding or inner entities to be deleted as well. That's why we're going to introduce the concept of own entities when we move on, and we'll see how the sections for this menu are owned by the menu, and the items for the menu section is owned by this menu section. And then when it's deleted, then it's cascaded and deleted as well. So we'll look into that when we start configuring this mapping. We're going to write this entire mapping, so we will have the database look exactly like this soon as the video progresses. So when we get to that, then I think it'll make more sense. Okay, so let's move on and start coding at last. Okay, so I have our project open in Visual Studio Code, and it corresponds to the diagram that we looked at before. The first thing I want us to do is to go to the infrastructure project and inside the persistence folder to create here our DB context. So let's go ahead and call it boorDinner DB context. And let's say public class boorDinner DB context. And this is going to be the DB context for our application, but because we don't have the entity framework core NuGet package yet, then let's go ahead and add it to the infrastructure project. So let's say .NET add, and we want to add to the infrastructure project the package Microsoft .entity framework core, and let's just fix the typo. So .NET. Let's run this. This will add the NuGet package to our application. Okay, and now we can say over here, DB context, and include the corresponding namespace. Let's close the terminal so we have a bit more room. And the first thing we want to implement over here is the constructor that will call the base constructor with the DB context options. So for that, let's say public, then let's put the name of the class, and let's say DB context options for our specific class, and let's call it options, and let's pass it to the base as following. Great, now let's create our DB set of menus. So let's say over here, public DB set of menu, and let's call it menus. Yes, and let's give it a getter and a setter. And because we're not initializing it from the constructor and we have nullable reference types, then let's shush the compiler and tell it that don't worry, this ain't gonna be null. Great, so we have our DB context. The next thing we want to do is to add it to our dependency injection IOC container so we can use it in the menu repository. So let's go to our dependency injection of the infrastructure layer, and where we have the add persistence method, let's go ahead and say services.add DB context. This also comes from the NuGet package that we just added. And let's say boorDinner DB context. And over here we have the options that we can use to configure which database provider we want to use. Now we're going to use the SQL Server database provider. So we want to say use SQL Server, and this comes from another NuGet package. That's because each one of the providers has its own NuGet package, so you don't need to add symbols and things that you don't need. So let's say .NET add to the infrastructure project, the package, yes, this thing, .SQL Server, and this will add the corresponding database, which inside has the method that we need to add this provider. And the next thing that we want is to put here the connection string, but we'll do that later. Right, so let's just add the namespace. And now that we have this, then we can go to our menu repository and use the DB context instead. But before we do that, I want to make this a bit cleaner. So let's create here a new folder and let's call it repositories. And let's put both of these repositories inside this repository. Let's just fix the namespace and then continue. Okay, great. So we have this. Let's get rid of the in-memory static list of menus and instead say boorDinner DB context, and let's say DB context. Yes, this thing, let's just say private read only, and let's inject it via the constructor. And then over here, we can use it instead. So we can say DB context and then add the menu. And then of course we want to save the changes. So it's actually persisted in the database. So that's called save changes. Now, of course, this is still synchronous. This is just a step in the way. Don't worry. So this won't stay like this for long, but as part of this video, this is what we're going to be doing in the repository. Okay, so we have this. Again, we're only updating the infrastructure layer, the underlying database changed, but the application and domain layer don't care. And that's one of the core principles in clean architecture, that we have the layers and then we can have the abstractions sit in the inner layers. And we also are keeping persistence ignorant that we talked about before. Great, so we have this. The next thing we want to do is define the mapping between the menu and the actual database tables. So for that, let's create here a new folder. Let's call it configurations. And inside here, let's create the menu configurations, which will have the configurations of the menu aggregate. So let's say public class menu configurations, and this is going to implement the entity type configuration for the menu. And let's implement this interface and receive the entity type builder for the menu type, which we can now use to define the conversion for the menu type. Now I want us to look again at the table. So this is what we're going to configure now, and this is our menu entity. The first thing we want to do is define the menus table. So let's start with that. And to make this a bit cleaner, let's create here a method, and let's call it configure menus table, and let's pass it the builder, and let's create this method below. Then over here, we can start defining what it's going to look like. So we can say to table and call it menus. Now this is the default, but I just want to be explicit as part of this video, just so you see more methods. And if you decide that you want to be explicit in your application, then you know how to do it. Okay, so we have the table name, which is menus. Now let's start defining this. So let's open the menu on the right, and let's close the file explorer so we can see something. So opening the menu aggregate, then let's start with the menu ID, which sits inside the entity, which is referenced by the aggregate root, right? So I'm reminding you, we have the aggregate root, which extends the entity, and over here we have the actual ID. So let's first configure this ID. So let's say over here, builder, let's say has key, and the key for this table, like we said, is going to be simply the ID, because the aggregate ID is unique within the entire system. So we can say m.id, and that's it. The next thing we want to do is we want to define how the menu ID is going to be mapped to the database. Because I'm reminding you, if we look at this menu ID, then it's a value object that contains inside the actual value, which is what we want to store in the database. So the way we do that, we can say builder, then we can say property, then we can select the ID property, and we can say what the conversion is on the way into the database and what the conversion is on the way out of the database. So we can say has conversion, and then we can say on the way in, then let's take the value, and on the way out, let's take the value and let's create the menu ID using this value. So we can say create and pass it the value like so. So this is calling the create method over here, which simply returns the menu ID. We're still missing in the menu, in the domain layer in general, many enforcements of invariants. This is a topic that we'll cover in a future video. What's the difference between domain validation, application layer validation, and what are invariants? We haven't talked about that yet. So don't worry, we'll talk about all of that in an upcoming video. So for now, this is what we're going to have. Also, another thing is that by default, Entity Framework Core tries to generate the value for the ID. And because we're generating it inside our domain layer, then we need to say over here, value generated never. And that's it for now. Maybe soon we'll see how we can do it across all of our types, and we won't have to write this again and again for each one of the types, because all of our types currently generate the ID. Okay, moving on. So we configured that this is the primary key. It's a GUID because that's the value of that's the type of the ID. And that's it for now. Let's go ahead and add the name and the description that both have a maximum length of 100 characters. So let's say builder, and then let's say property, and the property that we want is the name, And over here, let's say it has max length, and let's say 100. And let's do the same thing for the description as well. So let's say description has max length of 100. Okay. The next thing we want to do is we want to take the average rating and flatten the average rating value object that we have over here. And like we said, we're going to do that with owned entities. And this is a feature that's called table splitting or table sharing, where we have two entities that are sharing the same table, like we can see over here. So to do that, it's very simple. All we need to do is the following. We can say builder, and then we can say owns one, and select the property that we want. In our case, it's the average rating. And then by default, these are the names of the columns that we'll get, but we can customize it if we want. So we can say over here that we have the average rating builder, and we can define over here that for the property of the, let's say, value, then it has a column name of whatever we want and update it. But let's leave it for now because we're going to do this something similar soon for many of the other tables. Okay, so we have this. The next thing we want is to define that the host ID. So again, this is over here a value object that contains the actual value. We want to flatten this as well and store it over here. So let's say builder, and let's say that for the property of the host ID, then there's a conversion on the way in and conversion on the way out. So let's simply copy what we have over here and paste it below, and this will be the host ID. Great, let's just include the correct namespace, and that's it for now. The last thing we have over here are the two datetimes that we'll leave as default for now. Great, so we have our first table configured. So this is the menus table. Now let's move on to the menus section, which corresponds to this thing over here. So let's go ahead and create here a new method, and let's call it configure menu sections table. And let's create this method. And what we're going to have over here is the definition for how we're going to store this property, the sections property. And I'm reminding you that the actual data sits in the underlying field of the section. So that's the backing field for this public sections. And this is a list of menu sections, and each one of the menu sections looks like this. So it has a name, a description, and then the same story with the items that is stored as a backing field. Okay, so we have that. Let's go ahead and configure the menu sections table. So the first thing we want to do is similar, let's say builder, and then owns, this time many, and what we own many of is the section. And over here we have the section builder that now we can use. So let's say to table. So in our case, the name of the table that we decided is menu sections. So let's go over here and say menu sections. And the next thing we want to do is we want to define the foreign key that is the menu ID, right? So I'm reminding you, we have the menu ID, which is a foreign key, and it's coming from the parent entity, which is the menu. So let's say over here, section builder, and then we want to say that it has an owner and that it has a foreign key that is called menu ID. Great, so we have that. Let's move on to the menu section ID, the name, and the description. So we have the menu section ID, let's say property, then we have the menu, the ID, and we want to give it the name of menu section ID. We also want to say that the value for this is never generated, and also we want to define the conversion. So on the way in, we want to take the value, and on the way out, we want to regenerate this menu section ID, and let's call create. I see I forgot to create the create method, so I'll create it, and then I'll return to this part. Okay, so I created this method, and now this works as we expect. Okay, moving on, we have the name and the description. So let's say property, and let's say name, and let's say has max length of 100, and same thing for the description. So let's say description. Great, so let's see we're not missing anything. So we have the name and the description which both have a maximum length of 100. We have the primary key that is composed of both the menu section ID and the menu ID, and this is something that we haven't configured yet. So let's go back over here and let's define what the key is for this table. So ideally, what we would do is we would say section, and then over here, we would specify the properties that compose the ID. So we would say ID, and then over here, we would select also the menu ID, but because it's a shadow property and it's not accessible via the section object, then what we want to do is say over here the names of the columns that compose the key. So in our case, it's the ID and the menu section ID, like so. And that's it, right? So we have the menu sections table configured. Let's move on to the menu items. So the menu items sits inside each one of the sections. So similar to what we did with the menu and the menu section, then we'll do the same thing with the menu section and the menu items. So over here, we have the builder for the menu section entity. Now we can say over here that this owns many, and what it owns many of is the items. And then we have here the item builder that we can use to configure each one. We can configure the menu section items table. So first of all, let's say that the table name is menu items like we have over here. So let's say menu items. Next, we need to say that it has an owner. So with owner, and then we want to say that it has a foreign key. And now over here, it doesn't have only one foreign key, but it has two foreign keys, both the menu section ID and the menu ID. So for that, what we want to do is we want to say to specify both of them. So let's say that it has the menu section ID and the menu ID. Great, we defined this. Now we can go ahead and define the other things in our table. So currently we did only this, and we haven't defined that they're part of the primary key yet. So let's go ahead and define the ID. So it's similar to what we already did in the past. So let's say over here that we have the item builder, and we want to say that for the property of the ID, then first of all, value generated never. We also want to say that it has the conversion on the way into the database and on the way out of the database. So on the way in, we're taking the value, and on the way out, then we're reconstructing the menu item ID. So let's say menu item ID, and let's say create, and also here I forgot to create the create method. So let me just create it and come back. Great, so now we have the create method, so we can pass it the value and reconstruct our ID. We also want to give this column a name. So let's say has column name, and the name that we gave it was menu item ID. So let's call it over here, menu item ID. And that's it. We also have the name and the description, and then we want to define the primary key. So let's go ahead and let's copy what we have over here because it's going to be similar. So let's paste it here. Let's fix the indentation, change this to I, and same thing over here. Great, now that we have that, the next thing we want to do is we want to define the primary key. So like we said, this time the primary key is composed of both of these foreign keys and also the menu item ID. So to do that, let's say the following. Let's say that it has a key, and the key, again, because we're using shadow properties in the definition of our composite key, then we need to define the column names. So the column names is the two columns that we defined over here, and also we have the ID. So before we put the explicit name, but of course we can also do name of, and over here we can say that we want the menu item and the ID property, which will give us the string ID. And then if we change the name of this property in the future, then we didn't break the database as well. So it's just a better practice to use name of and not what we did up here. Great, so it looks good, but even though we configured everything and it corresponds to what we have over here, there's one more thing that we need to do, because I'm reminding you again that the actual items, if we go to the menu aggregate, then the actual items that sit behind the sections property is the private list of sections, and same goes for the menu section with the items. So we need to go ahead and define that that's the field that we want Entity Framework Core to populate, that underlying field, and not the iRead-only list that it can't, right? So let's go ahead and do that. So let's say over here, builder, and then we want to say in the metadata, find navigation, the navigation property that we want to find is the sections. So again, we can say name of menu dot sections, and then we want to say that the access mode, so the set property access mode, let's say property access mode field, and this will give us what we want. This method returns null if it can't find the section, but we know the section will always be there, so we can tell the compiler to chill. Okay, so we did this. We need to do the same thing for the items. Now, I don't know why the find navigation isn't available on the nested builder. Then this is what I default to in nested builders. So let's say section builder, and now let's find the navigation that we want to configure. In our case, it's the items, right? So items, and then over here, we want to access the metadata and to define that the backing field for this property is the items. So let's say set field, and let's say items, and let's now define that when we're accessing the items, then we want to use the access mode of the field like we did before. Great, so we have this, now it's fully configured, and we can move on to the last two tables, which are the menu dinner IDs and the menu review IDs, which are both a list of value objects. So let's go back over here to our main configure method, and let's define here the configure menu dinner IDs, and same goes, instead of dinner, let's say review IDs, and let's create the corresponding method. So starting with the dinner IDs, then we have the builder where we know the drill, so we want to say that it owns many of the dinner IDs, and now we have the builder for the dinner ID table, and we can say the following. So to table, and this we want it to be menu dinner IDs. We then want to say with owner, and then has foreign key, and the foreign key, like we said, is the menu ID corresponding to this thing over here. Great, so moving on, we want to configure now the primary key for the table. So we can say over here, has key, and like we said, we do want this to be an auto incrementing int that will be generated by the database. So for that, let's say has key, and let's simply say over here ID. This will generate a shadow property for each one of the dinner ID objects. So I'm reminding you that the dinner ID object looks like this. So it has inside the value, which is what we're actually storing inside the database. So we'll create a shadow property called ID, and it will populate it with an incrementing value when it's stored in the database. So let's go ahead and configure this property. So the value property we want to store under the name dinner ID. So let's go over here and let's say that for the property of the value, then a few things. First of all, has column name of dinner ID. Let's also say value generated never, and I think that's it, right? So this is what we're looking at. So we have the dinner ID, the menu ID, and the ID. So looking over here, we have the menu ID, the ID, and the dinner ID. Great. The last thing that we're missing is, again, to configure that we want to populate the underlying list. So going back to the menu, then we can see over here that for both of them, it's the same drill with the read-only list. And behind the scenes, we have the actual underlying list of dinners and reviews. So for that, we already know the drill. So we can say builder, and then we can say metadata, find navigation. Then we can select, we can need to give it the name of the property, that the navigation property. So in our case, it's menu.dinner IDs. And then we want to say that when it's accessing this property, then we want it to populate the underlying field. So for that, let's say property access mode, and let's say field, and let's just give it an exclamation mark so the compiler can relax. And let's do the same thing, but instead, let's call this method configure menu review IDs. And then let's basically take every place where it says dinner and replace it with review, right? So let's say dinner, and let's change it with review. Great, so we have that. Let's see if it compiles. So no, we have the dinner review IDs. And let's see if this works. No, so let's say menu review IDs, sorry. Yes, let's see if this works. And over here, also, we want to change this to menu review IDs. And that should be it. So we have all of our 5 tables configured. Again, this method over here configures 2 tables, also the menu sections and also the menu items. Now that we have all of this defined, then let's first build our application and see that it builds as we expect. So running .NET build. Okay, so I can already see that we have an error and that I'm missing a semicolon over here. So fixing this, and let's rerun the build. Great, okay, so we have our menu configuration. The next thing that we want to do is we want to generate the actual migration. So going back to our slides, then let's talk a bit about the technical details. So we added 2 packages up until now, the NT-Framework Core and the NT-Framework Core .SQL Server, which is our database provider. And the next thing we're going to do is we're going to add the .NET CLI tool of .NET EF. And this allows us to create migrations, update the database, and so on. But for creating the migration definition, then we need another NuGet package, which is the design NuGet package. So let's go over here and let's say .NET tool, and then we want to list all the tools that we have globally and see if we have .NET EF installed. So I already have it installed, but if you want to install it, then all you need to do is say .NET tool install, and then to install it globally, that will install it. But because I already have it, then I don't need to do it. Now what we want to do is say .NET EF, and then we want to create a new migration like it's suggesting over here, but let's write it out so it's easier to comprehend. So we want to call the migration initial create. The project that contains our DB context is the infrastructure project, right? The infrastructure project. Then we would need to define what the startup project is. So we can say startup project, yes, and we want this to be the API project. Now you can write it also in a more concise way. So over here, you can simply say -p, and over here, you can say -s. So that's what we're going to do from now on, just because some of you are watching this on a phone and the text is giant. So just to make things a bit more concise. Okay, so we did this. Let's click enter and see why it might not work. Okay, so it's failed, and that's because of what we just said. So we need the API project to reference the design NuGet package. So for that, let's say .NET add, and we want to add to the API project the package Microsoft.NT-Framework-Core.Design. So running this will add it, and then we'll run the creating a migration again. So let's say now the same thing. Let's run this and see if it was able to generate the migration successfully. If not, then we'll try to understand why. Okay, so it didn't work, and we can see that we have no suitable constructor found for the dinner ID. Now it's giving the dinner ID, but in fact, if we look at our domain layer, then let's look at the menu, for example. Let me close all of this. So looking at the menu, then this probably bugged you if you're familiar with NT-Framework Core already. So we can see that we only have public getters for all of our methods. And also we have this constructor, which in our case, it's private, but even if it wasn't private, then all we have is this constructor that requires many arguments. And when NT-Framework Core tries to create an instance of the menu, then it uses reflection, and it can't do it with this constructor. It needs a default constructor. So for that, let's go ahead and create a default constructor in all of the objects in our domain layer that have to do with the menu. So that includes the menu, the aggregate root, the entity, and all the various entities, the other entities that we're using. And also let's change all the properties, instead of being only get, to be get and then private set, right? Like this. So let me do that for all of the relevant entities, and then let's continue. Okay, so I'm back, and what I did off camera is the following. So looking at our domain layer and then at the menu aggregate, then I changed all the various properties to also have private setters, like we can see over here. And I also added a private parameterless constructor for the menu, but not only for the menu, also for the aggregate root and for the entity as well. So as you can see over here, and I did the same also for all the various relevant entities. So for the menu item, for the menu section, basically any object that Entity Framework Core will try to instantiate using reflection. So it needs a private parameterless constructor, and same thing with the private setters. So now that we have that out of the way, then there's one thing that I did forget to do, and that is in the Boober Dinner DB context. So what we want to do is we want to tell Entity Framework Core to scan the assembly, find all those entity type configurations, and add those configurations. So to do that, we want to override the onModel creating method in the DB context. So let's say over here, override, and then we have the onModel creating method. And over here, we can say model builder, and then apply configurations from assembly. And over here, give it the currently executing assembly or the Boober Dinner DB context, whatever you prefer. So I'm just going to say type of Boober Dinner DB context and select the assembly, but you can do whatever you want, pass the assembly marker or however it's implemented in your service. Also, I wanted to say that this is the place if you want to specify that for all the entities in your DB context, then you don't want to generate the ID for the primary key, then this is where you can do it. You have the model builder, you can iterate over all the entities and say that you don't want to generate the value for the ID. I'll link the code over here, the snippet of code that you need to put for you if that's what you want to do. Okay, so we have this out of the way. Let's try creating a migration again and seeing if it works. So let's say over here, .NET Entity Framework Core migrations add, the name of the migration, and then the details. Let's see if it works. Okay, so to my surprise, it failed. This is the first time that I didn't expect it to fail. So let's debug and understand what the issue is. So looking for the actual error, then we can see the following. You can see the property menu section ID cannot be added to the type menu section because no property type is specified. Okay, so it says that there's no menu section ID type. So let's go to the menu configurations and let's look for the menu section ID, which is inside the menu section. So let me close the terminal so we have a bit more room. So we're in the menu section and we have the menu section ID. And yeah, now I can see the mistake. So I'm looking back at our diagram. So let me open it over here. Then we can see the following. So we want the primary key to be composed of both the menu section ID and the menu ID, right? But what we gave it here is the menu section ID, and this doesn't exist, right? So this ID is talking about the ID property, and the menu section ID needs to be changed to menu ID, right? So let's change this to menu ID. Let's try building or creating the migration again and seeing if it works. Okay, so the migration was created successfully, and we can all sigh in relief and make sure that this looks like we expect. So I'm looking at the migration definition, and we can see we have here some errors, and this is caused by rules that we have in our editor config. So we can go to the editor config and tell the compiler to ignore them by saying that everything in the migrations folder just is considered as generated code. So we can say generated code equals true, and this should get rid of all the various warnings. Great, okay, so we have the menus table, and we already remember this, I think, by now. So we have the ID, we have the name and the description, then we have the average rating value object, then we have the host ID and the created datetime. So let's see that it looks like we expect. So here, the maximum length is 100, like we expect, and it's the correct type. Then we have here a double and an int. Great, that's what we expect. For the host ID, then we are storing it as a string. So I forgot about this, but that's the exact idea of this solution, that we don't care about the underlying value. So currently it's a string, but it can change in the future. So something we might want to do is we might want to cap this to only be some length if we prefer. Okay, so we have the primary key, which is the ID. That's the ID of the aggregate. Moving on to the menu dinner IDs. So this is the table of the value objects. So this is where we generated an ID. So this ID that we're looking at corresponds to this over here. So we have this ID, which is auto incremented and created by the database. And we have here the dinner ID and the menu ID, which are simply properties. The primary key is this ID, the int. And then we also see that what we talked about, so all the various tables are configured to be deleted if their parent entity is deleted. Great, moving on to the menu review ID. So we expect this to be exactly the same because we did copy paste. So yes, same thing over here. We have the ID and everything here is as we expect. Moving on to the menu sections. So we have the menu sections. And if you remember for the menu section, so we have the primary key, also the menu ID, and also the menu section ID. So that's what we expect to see over here. And indeed, these are the primary keys. And we can also see that the values are as we expect. So we have the menu section ID, the menu ID, and we have the name of it and the description that are both 100 characters long. Next, we have the menu items. The menu items has two foreign keys, which is the menu section ID and the menu ID, and the ID of the actual menu item entity, which is this. But the primary key is a combination of all three of these. So that's what we expect to see over here. And in fact, that's what we have. So the primary key is composed of all three properties. Next, we can see that the name and the description are both only 100 characters like we defined. And that's it, right? So everything here is also like we expect. Great. So this isn't very interesting, so we won't go into this, but it looks like we expect. So now let's go ahead and create our SQL Server in a Docker container, and then connect to it, create the database, apply our migration, and see that everything works end-to-end like we expect. So going back to the slides, then we created the migration. The next thing we want to do is to update the database. So for that, what we want to do is we want to create a Docker container. So even though this is in the illustration like this, in actuality, it's going to be inside a Docker container because I'm working on Mac OS and the SQL Server doesn't run on it natively like it does on Windows. So that's what we're going to do. And also, so all the various platforms are happy. Also Linux, Microsoft, and Mac OS. And I was curious to see how the icons will look with eyes. So I left it. So if you were curious, then now you know. Great. So the first thing we want to do is we want to have Docker running on our machine. The next thing we want to do is to make sure that we don't have the SQL Server already running. So looking at that, we can see that there's nothing running currently. And also, I made sure to get rid of everything. So if we look at the images that we have, then I don't have any images either. Great. The next thing that we want to do is we want to pull the SQL Server image so we can use it to create the container. So for that, let's say Docker pull, and this will pull the image. Great. So now if we look at our images, then we can see that we have it installed. The next thing we want to do is to actually create the container. So let's say Docker run, and this is what we want. Let's walk through it. So we're saying that we want to accept the end user license agreement. Also, we're saying that for the system administrator, then the password is my bank password, which is amico123, and then an exclamation mark. And the port that we want to run on, we want to run in detached mode. And this is the image that we want to run. So running this should create the Docker container. So let's say Docker container list. And let's see what we have. So we can see that now it's running from 6 seconds ago. We can also do Docker PS. It's a shorter way to do it. And now that we have that, let's go ahead and try to apply our migration. So for that, we're going to use the NG Framework Core .NET CLI tool again. So let's say .NET EF and then database. And we want to say update. And we want to define that the project that contains the migrations is the infrastructure project. The startup project is the API project. And then we want to define the connection string, which is the following. So the server is a local host. The database is Brewer Dinner. That's the database that we want to create. Then we have the user ID, which is system administrator or system administrator. Then we have the password, which is the password for my LastPass account, which is amico123 and exclamation mark. We need to escape it. So let's escape it. And the last thing we want to say is encrypt false. This is because we're running locally. Of course, you don't necessarily want to write this when you're running this in production environments. Okay, so running this will apply the migration to the database. So let's give it a moment and see if it works. Okay, so it finished running and it looks like it ran successfully. Let's go ahead and make sure. For that, we're going to use a Visual Studio Code extension that's called SQL Server. So let's open the extensions and over here, search for SQL Server, and we'll find the first one, which has many downloads and somewhat love from the community. So let's go ahead and open this extension. And over here, we can see the databases that I already have. Let's remove them so we don't have any spoilers of what's going to happen. And let's add our database. So for that, we want to put the connection string over here. So same drill, server's localhost. The database we want to connect to is the Boober Dinner database. Then we have the user ID, which is the system administrator, and the password, which is the password for all my essential documents, which is amico123 and exclamation mark. Let's press enter, and this will connect to this database. So great, the profile was created and connected, and now we can see that it indeed created the Boober Dinner database. And inside here, we have all the various tables, and we can make sure that it looks like we expect. So we have the menus, for example, and here we have all the columns, and we can make sure that this looks like what we defined before in the tables. Great, so now that we have this, let's try running the application end to end and seeing if it works. So let's say .NET Run, and the project that we want to run is the API project. Let's go to our requests folder, and over here, let's use the create menu request to actually create the menu. But let me refresh the token and put here some valid details. Okay, so the server's running and I created a new token and I put here some details. This is just the details that we defined in the API definition. So I simply took it from there and I pasted it over here. Let's run the request and see if it's stored in the database successfully. So running this, let's give it a moment, and we should see also the output over here, and we see that it failed. Okay, now if you're wondering why it failed, then I want you to take a second and think why it might have failed. And the answer is that in the dependency injection of the infrastructure layer, then we said that we're using the SQL Server database provider, but we haven't specified the connection string which it'll use to actually connect to the database. So that's what we want to do over here. So you know the drill, I'll write it. Okay, so I wrote it out, and same thing like before. So the server is localhost, the database is Boober Dinner, the user ID is the system administrator, the password is the password that I use for everything important in my life, which is amico123 exclamation mark. And the last thing, you can either write encrypt false or trust server certificate true if you're working locally like I'm doing and you're following my steps. So both of them will work. And let's try running the application again and seeing if it works now. Okay, so I'm running the request and let's see if it runs successfully. And we can see a few things. First of all, we get the response, which looks good. And also we can see over here that we have the details of the request printed to the console. So let's query the menus table. Let's select the top 1000. And again, this is part of the extension that we added before. So this will create the query, run it for us. And here we can see the details like we expect with everything that corresponds to the response that we just got. Great, so we have that. The next thing we can look at is perhaps the menu sections. So let's say select top 1000. Again, this will create the query for us, query the database, and here we can see all the various values. And for the menu items, then we expect to have here the two foreign keys, both the menu ID and the menu section ID. So we see we have here the menu item ID, the menu section ID, and then the menu ID. And this should correspond to the menu ID and the menu section ID. So if I open the actual response that we got on the left, and let's keep this on the right, then we want to make sure that the menu ID really is the menu ID, like we can see over here. The menu section ID is indeed the menu section ID, and the item ID is indeed the item ID, right? We can see that it's configured like we expect. It's important to just make sure that the database was created like we expect, it looks like we expect, and that's true every time you do a migration. You just want to make sure that you're doing things correctly. So I think that's it for this video. I hope you enjoyed it and you learned something new. You have no idea how much time I spent preparing for this video and creating this video. So if you enjoyed it, make sure to smash the like button, leave a good comment, smash the subscribe button, and I'll see you in the next one.